Hello everyone, I hope that you are doing well. Let's talk about other soil orders. And in the last class, we talked about the jelly soils, histosols, and spodosols. The jelly soils are those soils with permafrost, very low temperature, or cryic materials that express cryoturbation. The histosols, those soils with thick organic layers or horizons, and the spodosols, those soils that express clay migration and concentration in subsurface horizon. But in this case, we have migration of organic clay and iron and aluminum oxides. In this class, we plan to talk about the Andisols and the Oxisols, two soil orders that are completely different. The Andisols are those soils which express Andic properties, a huge and strong effect of Andic properties. Okay, if you remind, the Andic properties are those properties that express low crystallinity minerals due to a recent or modern volcanism. So allophane, immolite, and other minerals, they could induce a high content, a high concentration of aluminum, silicon, iron, and other metals in soil solution. And these metals could create some organic and metal complexes that induce organic matter accumulation and could create some dark horizons. Okay, but also in this specific case we can see that even those horizons that cannot accumulate high organic matter contents, they also express some properties of these andic materials. Okay, these soils are really common in areas like Japan, Asia, and other sites and regions that express an active and recent volcanism. It's quite funny because when we see the morphology of the soil profiles, they can remind us the spodosols, okay, because we can see very easily some dark and very dark layers and some white layers. So could tell us, okay, maybe we express at any kind of clay migration and clay concentration, but no. Okay, for the Andisols, they express these differences of color according to the difference of parent material or any kind of recent or modern sediments that concentrate, that accumulate in the surface because volcanic activity. Okay, so each color here, they did not express horizons that could lose clay, that could suffer clay alluviation, and because of that create this white color. And in these horizons we had concentration of clay and created yellow, red, or dark horizon. No, in this case we have differences of color because sedimentation of ash and other materials, other volcanic materials. Okay, to classify a soil as a Andy soil, First of all, we need to be sure that this physical soil profile did not follow all the criteria, that not cannot fulfill all the criteria for the previous soil orders. So for to be classified as an Andy soil, this specific soil profile cannot be classified as a jelly soil, cannot be classified as a histosol, or cannot be classified as a spodosol. If this soil profile that cannot fulfill all the criteria to classify this soil orders, we need to check if it has a strong evidence and strong influence of index soil properties. So if this specific soil possesses 60% or more of thickness, which is strongly influenced by index soil properties, so I can have an index soil, okay? But these horizons and layers that express a strong influence of index soil properties, they should be found in some specific depths. If this soil did not possess a densic, lithic, or paralithic contact, it also not possess a turripan or a petrocalcic horizon. So if this physical soil profile did not present any cemented material, any horizon or layer that express a very low weathering, so in this case, this index soil properties, this strong influenced horizons and layers should be found in the first 60 centimeters from the soil surface or the top of a specific organic layer with index soil properties. Okay, so think that we have the soil surface or the top of an organic layer with index soil properties. From this surface up to 6 centimeters in this thickness, we need to find a strong influence of index soil properties. Okay, if this physical soil profile possesses a densic, a lithic, or a paralithic contact, so possess a R layer or some layer that evidence an incipient weathering, or possess an horizon that was cemented as a Duripan or a petrocalcic horizon. In this case, the thickness between these cemented horizons or this lithic contact and the surface should comprise a strong influence of index soil properties. The other soil order that we need to talk about is the oxisols. The oxisols are deeply weathered soils. So these soils, they are commonly formed in wet and hot climate conditions where this high amount of water and high temperature could induce an intense destruction of the parent material, intense destruction of easily weatherable minerals, and create very thick soils with specific soil properties. Okay, these physical soil properties, they are related to low activity minerals. So it's quite common to find soils that are slightly plastic, slightly sticky in this case. They are slightly hard, so the consistency of the soils is quite easy to work, okay, in different conditions of moisture, but at the same time, this specific soil profile also, this specific soil order, I'm sorry, also could help the production and agriculture production, because a lot of water could be stored in this very thick soil, and at the same time the majority of water that is stored in the soil can be easily accessed by the plants, so the roots of plants can easily absorb the water that it's storage in the oxisols, because we have a low whiting point due to a low activity clays. Okay, the sand fraction of these oxisols are generally composed only by quartz, because all the other minerals that could easily be destroyed by the weathering, like feldspars, plagioclase, olivine, and others, already were destroyed during the formation of the soil order. And the clay fraction is composed by essentially iron and aluminum oxides and kaolinite, halite, and specific 1-to-1 minerals. Okay, the oxisols, they are essentially related to rainforests or dense forests and savanna, okay, areas that express high temperature and high precipitation. And it's quite common to find that these oxisols also express a high biological activity. Some scientists, they already says that the oxisols are biological soils, or they are soils produced by biological activity, because it's quite easy to find that the occurrence, the spatial distribution of these oxisols, they are straight related to some organisms, like the termites, for example. So these specific soils, they express intense bioturbation, intense biological activity, and it's quite common to see that the difference of color, structure, texture between the horizons which compose the oxisoils, it is very low. So we of course can see a darker color in the surface because the apparence, or because the melanization of the surface, but here we hardly can identify specific horizons or the boundary, the transition between the horizons, because the bioturbation makes all the materials. In this soil profile, is even harder to identify the transition between the horizons. And in this picture, we can see a redder color than the previous soil profile. This is because the oxisols that can be easily formed by the weathering of any parent material that you can think. So the oxisols, they could be formed by the weathering of limestones, granite, gneiss, schist, colluvial, alluvial sediments. Any kind of plant material could create an oxysoil, since this specific parent material suffer a strong weathering and leaching. In this picture, we can have an idea how the oxysoils could be very thick. So you can see some cars here, and in this zone we have a variance of 6 meters. So we know that these oxysoils could achieve huge depths. And here, something that highlights is this specific rainforest over these oxysols. The oxisols, they possess the oxic horizon, so they concentrate oxides, aluminum and iron, and sometimes even manganese oxides, but they also, some of them also could comprise an absolute concentration of iron and aluminum as some specific layers and horizons. Okay, so it's quite easy to find some cemented bodies in these horizons and layers that comprise cemented materials, in this case iron rich cemented materials. In this picture, we can see more details about these cemented layers in this oxysol. In this picture, we can see that we don't have any cemented layer, but we have a lot of bodies, nodules, and concretions that express cementation of soil, and at the same time we have the oxic horizon that expresses an intense leaching and weathering of this material. Okay, we also can see the same in this picture, like a lot of nodules and concretions which comprise a very thick soil profile. And the required criteria, the required characteristics to classify an oxysoil, actually it's quite easy. First of all, this soil profile or the soil profile that you are describing in the field could not follow or could not fulfill all the criteria to be classified as the previous soil orders. So to classify an oxysol, I should know that this specific soil profile cannot fulfill all the criteria to be classified as a jelly sol or a hydrosol or a spodosol or an andisol. Okay, and beyond of that, this soil should present in the first 150 centimeters an oxic horizon. The oxic horizon, you should remember, is that horizon that possess low activity clay, because this specific horizon express a residual concentration of aluminum and iron oxides. Okay, so we need present a low CEC according to the clay content. Okay, and the texture or the clay content between the apaton and the overlying horizons and the oxic horizon should be similar. So the oxic horizon comprise one of those horizons that we cannot register an increment or an increase of clay content. Okay, and in this first 150 centimeters, I cannot found a candic horizon. Okay, or this is one of the options, and the second option to classify, to identify an oxisol is that we have a soil with at least 40% of clay content, okay, in the first 18 centimeters, and I need to check a candidate horizon with the weathering mineral properties of an oxic horizon. So I should present a candidate horizon which, for example, the sand fraction, it's composed essentially by quartz. So the sand and silt fractions, they express an intense weathering. This candidate horizon also should express low activity clays. So I need to check that this specific soil profile suffer an intense weathering and leaching. And I should possess a candidate horizon with very low content of rock structure, of rock fragments, of any kind of gravel which could express the parent material of the soil. So if I found an oxic horizon in the first 150 centimeters, it's one of the options to classify an oxysoil, and the second one is to find in the first 100 centimeters a candidate horizon with soil properties that are quite close to the oxic horizon, and between the surface of the soil and 18 centimeters, I found at least 40% of clay. Okay. In these cases, I can classify an oxisol.